to diagnose our patient. And these days, many intraoral scanners are advanced, and in our hospital we always taking intraoral scan data and analyze this data using AI model program. Until the AI model program developed, we have to use my hand to measure the teeth or something like that using your hand manually. You need to first the teeth size. You always measure the teeth size for your patient. You always measure on that. And we have to measure the all teeth. This is a digital caliper. I have been using this digital caliper to measure the teeth size. However, AI model automatically measure all teeth and show the teeth size immediately. Yeah, and so we just look at the number. And so actually, I am not using this program, and my staffs are using this program and making the result and they show the result. That's it. It's a very easy and simple program. And the Bolton ratio, teeth size Bolton ratio, arch width, arch length discrepancy. That's all informations we have to know. AI technology has been proved by manual method, and first the ICT program was proved by an article, and so we can access our homepage eyesightolso.com. Type eyesightolso.com. You can access our articles and several kinds of articles, and you can download the articles and read them. And the second program that we proved the AI program by manually, and 2,100 plus dental models the scan, and then two orthodontists measured the teeth size. They compare them, and so we can get a similar result between manual measurement and AI measurement. This journal is bioengineering, and the impact factor 3.8 is a very relative high impact factor. And so these images are abstracted from articles, and the AI program automatically detect the number of teeth and achieve this. Firstly, our program segment the teeth from gums automatically, and so the AI technologies like this, like machine learning. The machine learning technology are RNN models. Basically, fixed reduced nearest neighbor model, and we use this machine learning technique to separate the gum and teeth. I'd like to explain a little bit about the FRNN, and it's a little bit very complicated, difficult to understand our concept because it's engineering concept, not clinical concept. and so actually this use the hue saturation value, and so the representative word at the HSB, and so skip this. You can see the five round bees, and this one we can designate label one, and you can designate label 2. The label 1 means teeth, label 2 means gum, gingiva, and actually this stage training stage, and this stage is segmentation stage. You can look at five boards, and you can discriminate the label 1 between label 1 and label 2, and here, label 2. It's right. Do you have any opposition? Raise your hand. And so label 2, and this one, label 1, right? And then, how about this? How about one? So FRNN, fixed, reduced, nearest. So we label 1, ball. Label 1 is more nearer, and then we can classify this ball as label 1. So this area is a teeth area. This label 2 area is gingival area. So we can segment it teeth from gingiva. This is the concept. If you wanted to learn more deeply, you need to read the article and download the article from our insightors.com. Okay. And this is another technique, teeth detection. AI program detect the number of teeth, and so teeth segmentation and jaw curve extraction and tooth identification, number 16 to number 26. And then we need to pick up the point to measure the width and arch width. So this technique, the 3D key point detection technique, 3D key point detection technique. So this program detect distal point, major point, and cusp point. And so the engineer used the decentralized CNN technique to detect 3D key point. And this is the one kind of machine learning technique. Decentralized CNN, decentralized convolutional neural network. This is a sample article to show is a vertebra, and narrowing the vertebra number and detect key point to measure angle or the linear distance. Anyway, in panoramic view, we need to major point, distal point, center point, and detect key point detect. So we measured the plaster directly using the calipers by two orthodontists, and the AI program also measured the teeth size. So central inside, lateral inside, canine, first premolar, second premolar, first molar. And so we calculate the MA, mean absolute errors. And let's pay attention to the MAE values. under 1 millimeters, and especially on first molar, the MAE value is a little bit larger than other teeth. The first layer is one orthodontist, the second orthodontist. And the scatter plots, this area is AI program measurement, and this is two orthodontist measurement, the average measurement, and scatter plot that basically one line scatter plot, showing the one line and the scatter plots. And we can calculate the Bolton ratio from teeth size. Bolton ratio is very important. If the Bolton ratio is not fit, and the occlusion is poor, occlusal fitting is not good. And this is patient. This is means. It's Korean means. Then we can calculate the Bolton ratio until 6 from 13 to 23, and summarized 6 measurement. And this patient 50.8, and lowers anterior teeth 40.3 millimeters, and so Bolton ratio 79.3%. And this one is norms. According to the article, the norms is a little bit different. And the total Bolton ratio is upper 100.7, lower 93.5, and so Bolton ratio 92.8%. This is norm, and so a little bit bigger than the norms, and so we can guess the low anterior teeth is bigger than norms. We can calculate the normal and low anterior teeth summation, and the lower upper anterior 6 summation the 50.8, and the normal Bolton ratio, and then we can calculate 39.2, and now 40.3, and they calculated the summation 39.2, so 1.1 millimeter excess, lower mandibular 6 summation. So in clinic, we need to IPR to make a good Bolton ratio and interpretation. So we have 5 kinds of thickness of IPR board. And so if we pick up the 6 micrometer IPR board, and we can this Korean and this is 5 placement from canine to canine. And so 60 micrometer by 5 is 0.3 millimeters. And then we can do IPR 3 times. So we can IPR by 0.9 millimeters. And then 40 micrometer by 5 placement equal 0.2 millimeters, and 3 times, and one time is wrong, 1 time, and 0.2 millimeters, and result in the 1.1 millimeters. And so I uploaded my PPT so it's a break the array of the words. Overall ratio 100.7 by 91.3, and so the proper lower 6 summary summation 91.9 millimeters. So now 93.5 minus 91.9, so 1.6 millimeter. So from 6 to opposite 6, we need to IPR by 1.6 millimeters. So we can calculate the exact amount of IPR. And so our program shows the amount of IPR immediately. Yeah, this is Bolton ratio and IPR. Actually, it's not perfectly correct because a little bit this is imaging. However, we can report these numbers to adapt our clinical application. And so the one case is a row crowding and the IPR. This is result. That's very simple. And you can use the IPR gauge, the 0.1 millimeter to 0.5. And if you use do IPR, and you can check the amount of IPR. If the T size is wrong, then make malocclusion. If the upper anterior teeth are small, and they make diastema. In this case, you should not do orthodontic treatment, and refer to prosthodontist, and by yourself, you can add resin or making prosthetic treatment. This is from a small teeth. But sometimes you are trying to orthodontic treatment to close the diastema. However, the tight contact lower anterior teeth, you can close the upper diastema. But doctor were trying to close this diastema, and so diastema will not be closed. And then he grinded lower anterior teeth to make space for closed diastema. And I think it is the wrong diagnosis. He did not measure the anterior teeth. So we have to measure the anterior teeth or all teeth size. Yeah, this is a sample. And large anterior teeth crowding area. So two large anterior teeth, and we need to IPR, do IPR and correct that crowding. Yeah, this is case. And the small premolar teeth. In this case, the angle classification can be half cusp class 2. And it is very difficult to correct, make good interpretation due to the small premolar teeth. This is case. It's a small premolar and not good interpretation. And reversely, large anterior teeth and small premolars. Large anterior teeth and the small premolars, and not good interpretation. Actually, in this case, we need to IPR on anterior teeth and move posterior teeth anteriorly, making good interpretation. However, it's not perfect. Three, arch length analysis. As you know, arch length analysis is a required space minus available space. And the number is plus the crowding, number is minus spacing. So required space is summation of teeth size. And available space is we can measure the available space by 4 segments from 6 to 4 mesial, 6 distal, 4 measure. And canine distal and number 1 measure. So we can divide the 4 segment, and this 4 segment is not correct, I think. So we need more segment, 6 segment. Measure teeth size 1 by 1, and the segment the 6 by 4 3 2 1. Upper side is the same. So required space, red required space, the black available space. Arch length discrepancy summation red minus black area. Our program shows arch length discrepancy, automatically shows the result. Arch length, according to the arch length discrepancy, our case can be divided 3 types. Number 1, mild case. Mild case, arch length discrepancy is within 0 to 4 millimeters. In this case, we can treat without any premolar extractions. So expansion or IPR, something treatment. The moderate case is from 4 to 8 millimeters discrepancy. And this case is upper 5 millimeters, lower case is 3.5 millimeters. And then we can classify this moderate case. In this case, we can try to this case without any premolar extraction. And the third case, the severe case, over 8 millimeters. Over 8 millimeters is difficult without premolar extractions. And this case, upper 15.2 millimeters and the lower 9.2 millimeters. And the floor, temporal and the basal arch widths. You should measure the intercanine width. Intercanine width is very, very important. Actually, without scatter expansion, we can change the intercanine width. So intercanine width. This one is norms of Korean. And the more important thing is the normal difference is 7.5 or 8 millimeters. You should remember difference. The interpremolar width. Interpremolar width usually first premolar. And upper 41.7, lower 30.9 millimeters. And normal difference 7.8 millimeters. And intermolar width, the first molar, the mesobuccal cusp-T. Upper 52.1, lower 40.7 millimeters, and the normal difference 7.4 millimeters. So I suggest you only memorize 8 millimeters difference. These programs detect cusp-T, mesobuccal cusp-T, canine teeth. This program adapt the depth profile, and from image, cut the cross-sectional, and P1, P2. P2 is mesobuccal cusp-T. And so this program adapt P2 as a mesobuccal cusp-T. And this program recognize the mesobuccal cusp-T as P2. So it can automatically the intermolar width. especially premolar and first molar, canine tip is not problem. This article compared the proposed methods. So AI programs, method, and measurement. And you can compare, you can see the canine area, first premolar area, and the first molar area. And you can recognize that first molar area is a large deviation because actually people has a weird visual vocal custody. So AI program detect precise visual vocal custody. So when you use AI model program, you need to check the exact landmark of visual vocal custody before you're using the result because it's a little bit limitation of AI technique. Blend Altman Plus, and so this is the first molar, and this is the agreement limit. You can see agreement limit, and so first molar area, first molar visual vocal custody is very diverse and diversely spread. The canine, the first molar, is a little bit focused one agreement or limit. So you can see arch-width discrepancy. This program has adopted norms from Yonsei University, and so a little bit different. As I showed the norms, the Korean Orthodontic Association suggests the norms, and this norm is shows suggested by Yonsei University. So we need to focus the very smaller arch with the discrepancy. This is the warning signs that we need to expand the skeletal. I showed the dental arch with this, and we have to know the basal arch with this. Basal arch with this shows us we have to expand the skeletal or not. This is dental arch with this, and so we can see the difference, normal differences, and 8.49. It's a little bit different according to the articles and the researchers. And the basal arch with this. This article shows the basal arch with this, and canine area, first premolar area, and the first molar area. On canine first molar area, the coronal third area is the basal arch with this landmark, and they are measured between left and right side. And the first molar area, the bifurcation area, they measure between left and right side. So we have to pay attention to here, first molar, the 0. After the severely different, if this patient has a severe difference between compared to norms, we need to consider the skeletal expansion. This is an article's case. You can see the RP case, and so after expansion, for the basal arch is the 5.1 from the initial 46.2, and after expansion 51.0 millimeters, and the skeletal expansion. And this is a Yonsei transfer index. I adapt this index, and this is the basal arch with this difference. It's almost 0. you have to remember this almost 0, and the dental arches difference is 8. In contemporary orthodontics, they showed this diagram, and in this case, it's posterior crossbite here, and second image is the posterior crossbite. However, the etiology is different. The etiology is different. The upper or left side image shows just the simple inclined posterior teeth lingually. However, right side image is narrow upper arch, narrow maxillary arch. So we need to approach it differently. So this is one case. 12-year-old female patient. It's about a middle school 1-year patient, and so narrow arch and lingually inclined lower posterior teeth. And her father is internal medicine doctor that asked me to treat his doctors. And I measured in this at that time you have no intraoral scanner, just take a plaster model and measure the plaster models and compare the norms. And at the first premolar area, the premolar width is very smaller than norms. And the first premolar, and the lower arch, and the first premolar and the first molar area is very narrow than norms. So PA analysis, and you can see basal arches, 38.3 millimeters, and mandibular basal arches is 45.7 millimeters. 7 millimeter difference, -7, not 0, right? And so one more thing, in this case, the upper molars are inclined buccally, lower molar inclined lingually. So in this case, we need to consider the skeletal expansion. So I used the RPE, not MARP, because she is too young. And so in low arches, the precision lingual arch is very effective to writing the buccally using this TMA wire. 20 by the Boston's TMA wire. So, and the bond brackets and the leveling and alignment. Yeah, after debonding. I wanted to control numbers, number 17. The doctor quit the job and go to the Ulsan area, so I could not keep going treatment for this patient. And then I measured the dental arch width. And so let's see the measurement. So almost norms, the premolars, first molars, lower first molars, almost same with the norms, and the proper occlusion, making proper occlusion. The PA analysis, the basal arch is 46 millimeters, and the lower basal arch is 46.0 millimeters. The difference is almost 0. The perfect occlusion. Yeah, and so I'm gonna show 2 more cases, and then we are doing hands-on. David, please click the case.